Greetings, I'm Dr. Fletcher, and I'm here to talk to you today about the global positioning system. I'll show you a presentation. We'll try to make it fun for you. And certainly, if you have any questions, you can email me through Cool Science, and I'll certainly answer those. But hopefully, as we go through the presentation, you'll learn everything that you need to know. GPS, or the Global Positioning System, is a satellite system that has up to 24 satellites on orbit and allows us to do a lot of great things here on Earth. Now, I mentioned Earth, and I think you're familiar with it. It's the place where you live. It's the place where you're born. It's a large, planet that floats through space daily around the sun, something you see and warms you each day. Now, the circumference, for those of you into geometry so far, is 24,900 miles. It rotates at about 1,000 miles per hour, for a one-day cycle. So it's going pretty fast, but you don't feel it because the effect of relatively being on the planet, you're always going that fast. It feels like you're staying still. Now, when you look into the sky at night, and I talk about satellites, with respect to GPS, our main satellite that we know is the moon. It goes around the Earth, and it's about a quarter the size of Earth, and its distance is 239,000 miles away from us. Now, the GPS satellites, or global positioning satellites, are not that far away. But if you wonder what a satellite is, they could be both natural and man-made. Now, let's take a look at the history of GPS first, because it's always fun to look at history to understand how we got to the places that we are now. Okay, getting some vocabulary here. Feasibility studies. What does feasibility mean? Feasibility means, is this something we can do? That's all that one word means, but it's better than having to write, is this what we can do? Studies began in the 1960s. And what that meant was, is it possible to put satellites in space that would allow us to be able to tell us where we are on Earth and navigate from one place to another place? And that's all that really means. Now, the Pentagon, it's a building in DC where a lot of good military stuff happens. Myself, I was an Air Force officer for over 20 years, working in space and nuclear operations. So a lot of my directives and orders would come out of the Pentagon for big programs. So what the Pentagon was asked after they did the what can we do studies, feasibility, is how can we fund it? So when they say appropriates, they're saying, do we have enough money? So they asked first, what can we do, and do we have enough money? So in 1973, the Pentagon said, yes, we have enough money to do this. And then we got around to 1978, we were able to launch the first GPS satellites. And these were the older GPS satellites, obviously. These would be your Block 1 satellites. We put them in different blocks right now to tell us where we're at in our progress. In GPS right now, we're launching, we have up Block 3 satellites on orbit and getting ready for the next generation of satellites to be up there to take over, because those satellites can't be there forever. Although some of the satellites that were launched back in 1978 lasted much longer than we expected them to last. So, when you have American ingenuity, sometimes you get more, we say bang for the buck, or we get more value for our money when we launch those satellites. And then after, 78 to 1995, it took to be able to get all the satellites we need. Remember, I said you need at least 24 up there. And in 1995, we were able to say, hey, we have a constellation that can do the work that we wanted to do. When we went all the way back to the 60s, said, what can we do studies? Getting to the place of, can we have some money from the Pentagon? Being able to launch those satellites in 1978. In 1995, we were able to say, yes, we have the ability to navigate from space. So after we worked with the military operations of these satellites, we saw there was great need and desire for these satellites' function to be here for everyone. So we opened it to the public in the year 2000. Now, when we talk about how GPS works, I teach classes to students who are in graduate school, but we're not going to go there right now and get you to that level. What we're going to do is get you to understand there's basic pieces to GPS and how GPS is used. We talk about the space segment. When I talked about those satellites being up there on orbit like the moon, but not as far out as the moon, that's what the space segment is. But they just don't go around by themselves and not have any kind of action to be tended to. We have a control segment. We have to control those satellites, because for them to give us accurate readings about where things are on Earth, they have to have very specific commands sent to them to make sure that they're accurate about where they're in space. And then there's the user segment. You all may have been part of or benefited from being part of the user segment, where, today a lot of people pull out their smartphones and they're able to use a GPS application. But with that GPS application, they don't understand all the science behind this like you guys will. So when you see somebody pull out a phone and say, hey, I'm going to use my GPS to go somewhere, you can give them an earful about the stuff you learned here, because they're part of the user segment. So the stations have to be positioned all over the planet. And I'm going to reduce my picture right here so you can see the slides better. The stations have to be all over the planet, so that we have references on the planet to be able to say if a satellite is in the right place where it needs to be. So there's a lot of good math going on to show where the calculations are going to make sure those stay in place. And then, like, these distances are calculated. And what you do is you have a signal, and it goes out, and then another signal comes back, and you calculate the amount of time it takes for the signal to go out to the satellite and come back to a ground control station to give a good idea of where the satellites are. If the satellites aren't where they're supposed to be, we make minor adjustments to get them to where they need to be, so we can have accurate readings here on the planet. The receivers use things called latitude and longitude. Now, if you ever look at a globe, you see the lines that are going up and down the globe versus going across the globe. That's what we're talking about with latitude and longitude. And we use those lines all the way back in history to be able to navigate ships before we ever had ships, and on ground, and then airplanes before we ever had a global positioning system on Earth. So when we talk about this science with GPS, the science didn't have to be invented. It was just evolved from what the science that we already had. Now, more satellites to the GPS receiver in the user segment can see, the more accurate your reading. And I'll give you a little bit more about that real soon to tell you what I mean by that. But the more satellites you can see with whatever thing you're using, whether it be a reader, could be what we call a plugger, it can be a smartphone, it can be big navigation rigs on ships at sea. And when those things read it, it tells you where you are, and it helps you know where you're going. The GPS can see the satellites. It does not work well in dense forests, inside caves, or underwater, or inside buildings, but we'll get to all of that. Now, when we talk about the distance from Earth, remember we said the moon was over 200,000 miles away from the planet as our natural satellite. But when we talk about GPS, we're talking about 12,000 miles from Earth. So you see that's a lot closer, and the GPS is going around the planet pretty fast, 7,000 miles an hour. 7,000 miles an hour make your head spin. But it is able to do 2 orbits around the planet in 24 hours. And here's a great thing right here too. We don't have, people to go out to space and refuel these satellites. They have big solar panels on them, like you see on some people's houses now, or out in the fields, or if you go over by the Air Force Academy, there's a whole farm of solar panels out there. So what it does, it gets powered by the solar energy. So when it goes around to the sunny side, extend those panels, and then that GPS satellite is able to be powered up and do its job. Now, GPS satellites are controlled and operated by the Department of Defense, but they're there for everybody to use. You need at least 24 satellites to orbit to make sure GPS is going to be a fully operational constellation. But there's been times when we have had as many as 30 or more satellites in orbit to be able to do the job. But we want to know that when we talk about a word called optimal, when we have an optimal constellation that allows us to do the mission of GPS, it's at least 24. And six satellites are within the field of view of any location at any one time. And when we talk about physical terrain, what we're talking about is that, we're out here in the Rocky Mountains. If a mountain's in your way, it can block one of your 6 satellites. So our main thing is to find that we have at least 4, so we can get our most accurate readings. Satellites constantly transmit their location and their time and data. which is good. So it lets us know, it's kind of like, I'm here, how are you doing? Oh, I'm doing fine with my receiver. Well, I'm here, so it lets us know where they are all the time, because we don't want to lose track of our GPS satellites, because if we lose track of our GPS satellites, we might lose track of where we are. And if you take a look at this picture right here, this is a good picture of what the satellite looks like in space. Now, those lines you see right there between the satellites, the satellites are not on tracks or anything like that. It just gives you an idea of how the satellites go around the planet and orbit it. And for those of you who've gotten into some more science, and you've seen like pictures of atoms, and you see how the electrons go around the nucleus, then you can see that, what we're putting around out there for our constellation, if you could actually see the lines, looks like a lot like an atom. Here's a picture to show you, the GPS nominal constellation. And when I say nominal and optimal, means the constellation in the best way that it works. It shows you 24 satellites, and we talk about 6 orbital planes. It means that they're not all at the same height. Let's say that for planes, and you'll have 4 satellites in each plane, and you want to have them staggered that way. We don't want the satellites all in the same plane. We don't want them all because it won't give us the best reading on the ground, and we don't ever want the satellites to run into each other. That would be a problem. I said about 12,000 miles, but when you talk about, you convert that, it's the altitude is approximately 20,200 kilometers and 55 degrees inclination. And that just means the way that it's pointed for you guys. We don't need to get into that too much. Space, the final frontier. Okay, I just quoted something that's probably older than all of you, but if your moms and dads watch Star Trek, they'll tell you a little bit more about that. So let's have a summary. We have 24 satellites. They're 12,000 miles above the Earth. They orbit the Earth twice daily, and there are at least 4 satellites in view for you at all times, unless get those pesky obstructions, and we'll talk about that a little bit later. The distance from the Earth to the Moon is about 256,000 miles. And like I said, as the Moon orbits, and I know earlier I said about 239,000 miles, but as the Moon orbits, we have variances in how far things are away from us based on the shape of the orbit. So, but that's for a much more expensive class later on in life. When we talk about the user segment, I said those people on the ground with some way of being able to access the GPS signal. Like I said, the original user was the military. But I'll tell you what, if you get lost, the people who are trying to find you, search and rescue, are also going to be taking advantage of using the capabilities of GPS. Disaster relief. We've heard all those stories about hurricanes and different things like tornadoes, and they can really tear up people's homes and that kind of stuff. When we want to go find those people, we want to get down there, we can use GPS to be able to help out with those kind of operations too. Now, let's say we want to build a house or a building or even a city. We want to know where things are going to be exactly, and we want to know those locations, and we want to be able to do it. Now, in the old days, a person would go out with a lens to look through, and another person would stand further away from them with a stick, and they would do that, thousands of times to be able to survey about how the height and draw lines to make maps. Well, rather than do that today, we were able to use GPS in that same way. The principles haven't changed on that. It's just how we do it and where we do it from. Marine, aeronautical, and terrestrial navigation. Those are fun things that you can do. Going on boats with your parents, or going on an airplane trip, or just going out to the woods and going for a hike and understanding where you are things you can do that are aided by GPS. And like I said, I'll tell you a little bit about something called geocaching later that maybe you can get out there after we talk, and you can start using GPS and get your parents involved with it. Remote control vehicles and robot guidance, that sounds really cool. If you have like a drone, or if you have a car that you control on the ground with a GPS, those are other fun games that you can do. Satellite positioning and tracking and shipping. When your parents get onto one of those online sites and they order something nice for you, like maybe they're going to order you a GPS controlled drone, they get on those sites and they order that for you. Now, the way your parents will know how close it is, you can say, "Mom, when is it going to get here?" is that they'll be able to look at an app that the shipper gives that tells you where that's at. Now, what's happening in that case is that the truck or airplane or whatever it's on is being tracked with GPS. And it can tell you almost to the point where you get a notification that says, this is going to be at your door in about 30 minutes. So those are the cool things we can do with GPS when it comes to like tracking. You know, when we're talking about doing some tracking and stuff like that with respect to shipping. Geographic information systems. GISs are just taking the data that comes from a GPS and making it useful in terms of putting on to maps or talking about different things. For example, if you're using a geographic information system for occasionally we have some forest fires, to take a look at the effects of those forest fires, where the burn areas are and how it's progressed, are all things that can be done with GPS, and also some of our imaging systems to be able to take a look at how things were one day, how they are now, and how things are recovering. And for recreation, obviously, if you want to go out and do some fun things, and you need to know where you are and where you're going, the GPS works very well. And that's where we get back into the thing I'll talk to you about a little bit later called geocaching. So when it comes down to it, this, you know, what does a GPS receiver do? It's not magic. It allows you to pinpoint your location anywhere in the world based on those things I said again, latitude and longitude, which we call coordinates. That's what it's looking at. So it's not magic. It's using some good science. It can tell you what direction you're heading, and you can say, okay, I was a Boy Scout or a Girl Scout, and or some other kind of adventure, a scout that I learned about things, and I said, I know that, you know, the sun rises in the east and it sets in the west, so that gives me some idea. Okay, that does give you an idea of where you're going, and you can look at a lot of other neat things you can learn to tell you where you're going. Something that's older, you know, we call precursor, which means a thing that comes before something else. A compass can tell you what direction you're heading in, and you know, so like I said again, GPS builds on a whole bunch of other things. You know, it can show you how fast, but GPS can also show you how fast you're going. It can show you your altitude, like where I'm sitting at right now in Colorado. I'm sitting at 7,100 feet, you know, 7,100 feet. And GPS can do that if I have the right amount of satellites. It can map to help you arrive at your destination. If you get in the car with your mom or dad, or a big brother or big sister, or uncle or aunt, or grandma or grandpa, they can put it in and say, hey, we're going to go on a trip over this holiday weekend, and we need to know how to get there. They may put GPS on, and you'll hear that voice that tells you, you know, left turn 500 feet. Or if they get off the path, they might hear recalculating, recalculating, recalculating. Okay, now when we talk about the importance of having 4 satellites in view versus 1 satellite in view, you say, well, I got 1 satellite. It costs a lot of money and it's a long way from the planet, so it should help me out. But the problem is if you only have 1 satellite in view and it's covering what we call a footprint, let's say that footprint is, you know, let's say its footprint is 2,700 miles, just as an example. It only tells me that the receiver is that, hey, you're somewhere inside of this 2,700 miles. And you're like, well, that's not very helpful. Where I want to go is only a couple miles away from me. If you tell me where I am just inside of a big circle, that's not too helpful. So, you know, in doing the things we need to do to be able to test the GPS constellation, we added more satellites. So now when you take a look at this picture and you see where that yellow dot is, you know, I'll point to it right here with the pointer. When you see where that yellow dot is, you say, now I have 2 satellites. That means I'm somewhere along that dot. So that circle gets smaller, but it still doesn't tell me exactly where I am. So we get 3 satellites, and you see the yellow dot now. It gets even better. I have a better idea of exactly where I am. But then but now it's we call 2-dimensional positioning. So I'm doing a lot better now, but you know, I can't tell what my altitude is, and I can't tell how fast I'm going. So when we add that other satellite in here, now we get to a place where we get 3-dimensional positioning, because we're not flat Stanley. We're not just like cardboard cutouts. 2-dimensional is not good enough for us. But for us to know exactly where we are, the altitude we're at, and how fast we're going, then we need that 4th satellite in there. And you see how these circles, as more circles get on top of the circles, we get more information. And that's how we talk about having 4 satellites versus just 1 satellite. So, you know, you're out there, and like I say, there's a thing called amnesia where you lose your memory. You have no idea where you are, and you walk up to somebody and you say, hey, man, where am I? and that person says to you, hey man, I can tell you that you're 625 miles from Boise, Idaho. And you go, wow, thank you very much for that, buddy. It doesn't give me much, but thank you for, giving me something. And then you walk up to the next person and you say, hey man, I just bumped my head. I don't know where I'm at all. Can you please tell me where I'm at? And that person says, hey man, you're 690 miles from Minneapolis. And you scratch your head and you say, hey, well, I did learn some things in GPS class. So you gave me another point. So now I'm getting better with this, because at first I'm 625 miles from someplace. Now I know I'm 625 from one place and 690 from another place. So I'm like, okay, I can do that. So you go ahead and write these things down, and you use the map in your pocket as a guide, saying, hey, I'm getting a little bit closer to understanding where I'm at. And then you walk up to another person and you say, hey man, where am I at? And that person says, well, you're 615 miles from Tucson. 615 miles. And you say, oh, wait a minute. Okay, I've been writing these things down. And then now you got your map in there, and you draw your third circle right there. You say, where do these things intersect at? And you see right there the little green dot in the middle of the map lets you know, hey, I'm in Denver. He said, then you go like, I'm glad that I listened to Dr. Fletcher in the GPS class, because that helped me to know where I am. And like those people that you're asking those questions to are similar to those satellites that you're getting your signal from. So as you get more satellites coming into place, and they're telling you your location relative to places that they know, you find out where you are. Now in this example, you had 3 points right there, because we're talking about a flat map. If you add that fourth satellite in, that fourth satellite can tell you what the altitude of Denver was. Now, when there becomes a problem with that is the phenomena of looking at things that are in the atmosphere that can get in your way. So you have buildings, you have cars, you have electromagnetic fields from wires that can all, and also just natural phenomena up in the atmosphere that can get in your way from being able to understand where you are, because everything, you're not always getting a clear signal down to your receiver. So what you have to do is you have to say, I know the error is there, and your good receivers will allow for that error, but you also can be smart yourself and say, let me take some of this error out. So if you're standing right next to a building or a canyon wall or something solid, you want to see if you can get out into a field a little bit more. If you're standing right by wires, you probably want to see if you can get away from those too, to make sure that you can get a better idea of where you are. But also, and not going too deeply into this, but what I teach to my graduate students, there's also things called GPS augmentation. And what happens with augmentation, there are things that are on the ground that understand that there's things that get in your way. So since these things get in your way, what augmentation does is that it allows for these things, and it helps you correct, so that it takes some of the guesswork out of these things that would not give you the best picture of where you are. So understand their sources of interference. The fact that we understand their sources of interference allows us to be more accurate with it. But also smart guys like you understanding the interference does exist. You may get away from a few things to be able to make sure that your GPS receiver is going to give you the best readings. So if you're out hiking, you want to stay away from the canyon wall. If you're doing your GPS to get the best readings, you want to do more of your readings out in the clear. And we'll talk more about that. And this is an example talking about the different kinds of obstructions. You have your satellites around, and you see 3 in sight right here, and you're trying to see what you're going to do. Those mountains might cause a problem. Those trees may cause a problem. And that water right there may cause a problem, because sometimes what can happen is that a signal from the satellite can hit this water and reflect off this water and give you a bad signal right there. So always be aware. So what you may want to do is, when you're out there with your receiver, is get a few calculations in that same area to see what makes sense the most, to make sure you're not getting a signal that bounces off the mountains or bounces off the water or bounces off these trees. Make sure you get the best signal you can. So always, to allow for error, beware of obstructions. Now, waypoints, that sounds cool. A waypoint is when you're going out there and you're trying to make your own trails. Now, let's think about this. When your parents want to get on the road, or your way to school, walking around the block, you get on the sidewalk, or they get in the street with their car, and they know where that street goes. When you're out in the woods or someplace that doesn't have those kind of markers for you, sometimes you got to make your own markers. And rather than going around and making marks on trees or building little mounds right there to remind you where you went. What you do is you make these virtual marks inside your GPS receiver so that you know when you get to this point, turn the same way as when you get to an intersection, you know, I'm going to turn left or right down Elm Street. It can be either a saved fixed position or user inner coordinates. Now, save or fixed positions are, for example, one of my classes, actually multiple of my classes, went to Garden of the Gods here in Colorado Springs, and they went out with their receivers and they mapped out a whole bunch of trails and courses so that when kids came there, they could pick up a booklet at the visitor center and just follow the trails that my students went over before. Now, if you're a pioneer, you might want to get out there and put those coordinates in to your receiver yourself so that you can remember the places you went, and you could also tell your friends where you went and they can do the same trails as you. It can be created from any remote point on the earth, so it doesn't matter where you are when you put that waypoint in. That waypoint is your waypoint, and when you share it with somebody, they can go where you were. So if you're doing a treasure hunt and you put your waypoints out there, everybody's going to be able to follow your waypoints and get to where you were. You know, it must have a receiver designated code or number or a user supplied name. So what it's saying is that you need to have a common way to access it. So there's using a smartphone with applications right there. There's also GPS receivers that your parents can buy, and you can go out there and you can put them in there and have a lot of fun with them. Some made by companies like Garmin and such that they can look at and research for you. Order with one of the companies, and you can track your GPS receiver all the way to your house, and it gets there. Then you can take it out and you can make your own waypoints. Once entered and saved, the waypoint remains unchanged in the receiver's memory until edited or deleted. So once it's in the memory, once you've been there and you got it in there, you're always going to be able to get back to where you need to go. And that's how, when we talk about geocaching a little bit later, people are able to go out and put waypoints in to get you to the place where the item that you're looking for is saved. And then you'll be able to save those and go do the things you need to do until somebody changes or gets deleted. So a lot of fun to be had with GPS. Now, when I talk about waypoints, to give you a better example of how that all looks, is that you see the stars where you start. Each one of these stars along this path represents a waypoint. And you see, it helps you to navigate around this marshy area, and you end before you fall in the lake. So that's probably a good thing. And you see here, as this river that comes out of the lake, it keeps you from out of the river and that kind of thing. And when you see these lines like this, the closer together they are, it shows elevation. So when you're doing your waypoints and you take a reading up here where the lines are closer together, it's going to show you from here to here along your path that you need to be fit and prepared, because you're going to be walking up some hills. Then you're going to be walking down some hills. And rather than just walking through a marsh, it shows you the safe way around a marsh between the river, and then you end up at your destination. And that's what waypoints are for. You know, and right here, when you're talking about this, you might want to, this is why you want to shoot a few different things around here, because it could be, if there's interference and other things like that, you want to make sure you're going to your true star as opposed to one of these false stars out here. So you'll be aware of obstructions and things like that. And also, you know, if you're out there and it's about to be a thunderstorm, you need to get yourself to a place where it's safe. But if you're out there and there's electrical activities going on in the atmosphere, it's going to make your readings be a little bit off. So what you want to do is make sure you're aware of obstructions and weather conditions and that kind of thing to be able to have the most fun with your GPS. Now, geocaching, I've been leading up to this for a long time. What is geocaching? Geocaching is simply a fun way to have fun with others using GPS receivers and locations. People do this all around the world, and they have hidden caches, like hidden treasure in different places at different coordinates on a website. And you can go to a geocaching site and it'll tell you. So if you go to the site and you download the coordinates for that, what you're doing is that those coordinates are those waypoints. You can go and find it. So you and your family get out there and you go out there and find a cache. And what you do is you can write your name to say that you found this piece and see if it's still in good repair. They might have a contact information for the person who put it out there if it's not in good repair. Or sometimes you see something is getting kind of messed up, and you may come back and put something nice there too, and just let people know that you updated the geocache. You know, and what you want to do is don't take the things that you find. You just record them, or you can take a picture of them to show that you saw it, so everybody can have fun after that. You know, this started in May, so you see that the constellation was released to the public in the year 2000, and by May of 2000, people are already out there saying, how can we use GPS to have fun? So, you know, it's been going on for 20 years now, using things that were originally for the military to be able to have fun with your family. And like I said, there's over 300,000 active caches in over 222 countries. So doesn't matter necessarily where you are or where you go on vacation, in what state, and in many foreign countries. If you're a geocacher, you can have fun and make that part of your trip or vacation. How do I start a geocache? You know, go to www.geocaching.com or another geocache site. Click on hide and seek. Enter a zip code of the state where you are and where you want to hunt. It'll give you some information on that. Put the level of difficulty. If you're just starting out, you want to go with the easy ones. And once you get to be more advanced, you'll be able to use some more advanced settings on that. Once you selected the cache to hunt for, you go out and find it. Make sure you do it in a safe way. Make sure you're always safe when you're out geocaching. Make sure that you don't go geocaching alone. Make sure you go with your parents or another adult or a big brother or big sister, and make sure that if it looks like that there's not a safe place to get something, go on to the next cache, because we want to have fun. We don't want to go to the hospital. Download or manually enter the waypoints into your GPS for the geocache, and then print out the page with the coordinates, hints, and logs, and then go have fun. You know, types of caches. Traditional caches can be any size. You can find any. I've been out geocaching. You can find anything from a piece of paper with something written on it to a little idol or something like that. So that's why I say leave them there so everybody can continue to have the fun. Usually have a logbook or paper or pencil for you to sign. So you go on there. It's like, I was here, so you write your name. Lou Fletcher was here inside the book, so other people can know you got there. So if you have other friends with geocache, they'll say, hey, Lou found this before me. You know, that kind of thing. Trinkets or items to trade with items you have bought. So if it's one of those caches where it's something you're going to take out of there, you might put another trinket in there. If it's a cache where you trade, and make sure you put something nice in there for somebody after they leave something nice for you right there. You know, may contain a travel bug, which is one of those things that allows you to understand where things are. And like I said, you'll learn more about those kind of things on a geocaching site. Micro caches are small containers, such as a film canister or magnetic key cases. Usually have to log them. You have to log in them or sign them to keep them so they can know you were there. And virtual caches are just spots or historic sites. So geocache can also be going like, I'm going to a certain point in the park where maybe there's a geyser or something like that. Another kind of virtual cache, which I know was popular a few years ago, was like when you playing a game like Pokemon Go. Those Pokemon characters are not actually there that you can see, but using that game, it tells you that there's a Pikachu in front of you or something like that. So that's another form of virtual caching. You know, multi-tier caches have clues to find inside out, be like a big scavenger hunt, and you can have a lot of enjoyment with your friends and family that way. And then benchmarks are permanent markers that are actually physically there for like surveying and such. So you can find it out. So you might, if you're trying to find out where, for example, if you're going to Four Corners, where, only place in the United States where 4 states touch, Colorado is one of them. You may go there and that would be a benchmark, 4 Corners. And like I said, I've given you some things here with some other geocaching sites. But if you just Google geocaching, you'll find all of these sites very easily. So no need to worry. If you want to geocache, you'll be able to geocache. Here's some educational resources. I use NASA a lot. When I was on active duty in the Air Force doing space and nuclear operations, I did a lot of training with NASA. So I know their stuff is really good. So NASA is a good one. And there's also other sites that tell you how GPS receivers work to go beyond what I talked to you about. Sites with similar activities, things that you can do. And like I said, whenever you do something and use other people's resources, always give them credit. So guys, that's about it. What I want to say is that, I'm sitting here on a virtual background of a starship. For us to get to places like this, we have to make sure that we understand the place where we come from, that big starship called Earth. And once upon a time, there was no satellites out there that we controlled. Once upon a time, there was only the moon. But learning the things that we learned about navigating on ground let us have the vision to be able to have satellites out there in a constellation to help us know where we are. So what are the next steps? As we learn more about space and we take more trips out to Mars and back to the moon, we're going to learn and understand how to navigate space even better as well. So you guys are the ones who are young enough to get excited about, global positioning system and things like using receivers for greater applications in the future. So when you guys have your feasibility study about what the future looks like, maybe you'll have something like this ship to be able to go on and guide you out into space. But for right now, have all the fun you can while you're here on Earth. Maybe doing some geocaching, learning about GPS, and teaching your friends. So this has been a great time to have with you, and I wish you well. Enjoy the fair, and like I said, this is recorded, so if you want to come back around and listen to it again, it'll certainly be here. Thank you very much. I'm Dr. Luke Fletcher. You guys have a great day.